Greetings everybody, and welcome to our fourth video in our series on cardinal numbers and set applications. So once again in this problem we are given a Venn diagram that has three sets this time. Each region is, the cardinality of each region is labeled with variables, and so what we're asked to do is that given the cardinality of various sets, we need to figure out the values for the variables. So let's jump in and see how we can do this. Really the trick to doing these problems is to start off with the region that's kind of the most restrictive. That's the region, or that's the set that really is only going to correspond to one region if we can find that. And kind of the first place that we can do that is with our set A intersect B intersect C. So where A intersect B intersect C is going to be where all three of these circles overlap. And so the only place where these circles all three overlap is here in this region W. And so what we have is that the cardinality of A intersect B intersect C, as we're given, it is W, and we're told that that cardinality is 8. And so we have our cardinality for W. And so for all of our variables, we know that the value of W is going to be 8. So now if we move to another set that maybe only corresponds to a couple of regions, one set that does that is our set A intersect B. So our set A intersect B is going to correspond to our values of X and W. And so since we know that the cardinality of A intersect B, that it's given as 13, then this is going to be our X plus our W. Well, what we know is that W has a value of 8. So this gives us 13 is equal to X plus 8. Well, subtracting 8 on both sides means that we really have 13 minus 8 gives us a value of 5 for X. And so we figured out our value for X. Now we can do a similar thing for some other sets that kind of overlap with our region W and maybe only one other region. And so if we turn around and look at A intersect C, so we're told that the cardinality of A intersect C is going to be 8. Well, which regions do that actually correspond to? Well, where region A and C overlap will be regions Y and W. And so this gives us 8 is going to be Y plus W. But again, we know what W is. So since W is going to be 8, what that tells us, if we subtract 8 on both sides, that we have a value for Y of 0. And so with Y, we have a value of 0. Now, let's do the same thing for B intersect C. For B intersect C, we have a value given of 14. And so the cardinality of B intersect C is going to be 14. Well, that's going to be our values where B and C overlap are going to be W plus Z. Again, we know that the value of W is going to be 8. And so if we subtract 8 on both sides, that tells us that Z is going to be a value of 6. And so we have the value of Z for 6. Now, kind of moving on down a little bit, we have looking at the cardinality of the intersection of A with B complement. So the cardinality of A and B complement were given as 24. So which regions does this actually correspond to? Well, we want the regions that are outside of B, but inside of A. So outside of B, inside of A gives us M and Y. Well, we know that y is going to be 0, and so what do we have as a value for m? M is just going to be 24. Now looking at the cardinality of the intersection of b and the complement of a, we have b intersect a complement has a cardinality again of 24. But now we're wanting the values that are inside b but outside of a. So inside b and outside of a gives us n plus z. And so here we know the value for z. Z is just going to be 6. And so if we subtract 6 on both sides, what we have is the value of n just being 18. So we have the value of n, 18. Now, let's look at kind of the sets that we've not used yet. So for our value p, we have p inside of the set C. And so they do tell us what the cardinality of C is going to be. So the cardinality of C given is 35. And the regions this is going to correspond to are y plus w plus z and then plus p. Well, we have values for these variables. So y we know is 0, w we know is 8, and z we know is 6. And so what that gives us is 35 is equal to 14 plus p. So now subtracting 14 onto both sides, what we find is that p is going to be 21. And so we have the value for p. That's going to be a value of 21. So finally, for the last set that we haven't used, is going to be the cardinality of the intersection of the complements of A, B, and C. So what we have there is A complement intersect B complement intersect C complement has a value of 12. So kind of writing these out, if we look at the regions that correspond to the complement of A, so it's everything outside of A. So that's going to give us N, Z, P, and R. If we look at the regions that are outside of B gives us M, Y, P, and R. If we also look at the regions that are outside of C, so outside of C gives us M, X, N, and R. Now for the intersection, we want those regions that are going to be common. So N is not common, Z is not common, P is not common, R we see is the only region that actually corresponds to all three of those sets. And so our cardinality of that has to only be region R. And so with that, we find that the cardinality of R is going to be 12. And so with that, we figured out all of the values for each one of the variables, kind of starting from the most restrictive, being the smallest number of regions that it's going to contain, out to the biggest, and kind of working our way from inside out from there. So I hope you've enjoyed this. I hope it's been informative, and I will see you guys in the next video. Take care.